This question states, state the de Broglie relation explaining any symbol you use. So the de Broglie relation is lambda equals to h over p, that particles can behave like wave having a wavelength lambda. So lambda is the wavelength, p is the momentum, and h is the Planck's constant. The part B of the question says that an electron of mass m has a kinetic energy E. So kinetic energy is represented by letter E. Show that the de Broglie wavelength lambda of this electron is given by this relation. So we know that wavelength is given by the relation which we have written in the above question, h over p. So it means we have to relate p equals to what we have to prove, that we have to prove that momentum is root 2 me. So if we want to show all the steps, so we write first the momentum thing equals to mv. So if we have to, as we have to make it kinetic energy, so mv square, so we take the square on the both side. Momentum square is mass square times the velocity square, multiplying half, because we need half mv square, half on both sides, so we get half momentum square equals to, I write m in a split form, so m into 1 by 2 mv square. So we have half mv square, which is the kinetic energy. So rearranging it, we get momentum square equals to, that 2 goes on the other side and turns out to be 2m e. The kinetic energy in this question is represented by e, so that's why, so momentum is equal to root 2me. So when we put this value of the momentum in the de Broglie formula, we get lambda equals to h over root 2me. So the question C says calculate the potential difference through which an electron initially at rest must be accelerated so that its de Broglie wavelength is equal to 0.4 nanometer. That is the diameter of an atom. So if we use the above form of the de Broglie equation, so lambda equals to h over root 2 me, and rearrange it for e, we get, squaring it and rearranging it, we get h square over 2m into lambda square. So electrical energy which is provided by a potential difference is equal to